Hi students, a very pleasant and warm greetings to you all. Hope you are doing good. Very happy to meet you through online class, and in this session today we are going to revise the exam portions alone, right? Exam portion already I think you would have learned it. We are going to revise the first 5 chapters today, and from tomorrow onwards we'll be taking the new chapters. That is from 9th chapter we'll be moving on. Okay. So today we are going to revise the first chapter first. First chapter, I think you all would have learned the generations of computer thoroughly. That's the main question. Generations of computer. First, you have to put each columns for generation, period, main component used, and merits and demerits. Right. So first generation. It is 1940 to 1956. So if you are learning with your guide or something, you just refer the year with your textbooks also, because in each books, it even if it is the old edition books also, there will be some differences in this generation's year. Okay, so just check it with the book and then learn it. And first generation, second generation, third, fourth, and fifth generation. And don't forget to write the component also. In sixth generation, in the component, you can write like robotics or human brain and artificial intelligence, like that. It's They have given a image like human brain interacting with artificial intelligence. So in that case, you can write either artificial intelligence or robotics or anyone. And in merits and demerits, try to write at least 4 or 5 merits in each generation. Okay. So first important question in this first chapter is generations of computer. Okay. So the next question of this chapter is data and information. Data and information, in the sense we have uh, a definition for data, a definition for information. That is either a differentiation between data and information, or else it will be asked separately for a 2 mark also. Data means it is unprocessed collection of raw data. Information, in the sense, it is a collection of facts. That means a conclusion will be made from that data. Okay, that is information. Data means it is a unprocessed collection of raw facts that will be useful for communication, or maybe for any other processing or anything. Data means you can say a name, Jenny, or one, or anyone, a roll number, or any age, like that. Any unprocessed data, just a name or just a number will be there. And in information means it is like my name is Jenny, like that. If there is a whole information or a collection of facts from where you can come to a conclusion, we'll say it as information. Okay. So if simply a name or a detail is there, if simply a number or a grandmother, a father, mother, like that, if a single word is there, we'll say it as a data. And if there is a whole sentence, that is like she is uh, her mother, like that. If there is a whole sentence and if it gives a full information or a meaning or collection of fact, from there we can know something means, we'll say it as a information. Okay, so this data and information is the next part, and the first one is generation of a computer. Okay, so first of all you have to know the definition for computer, and then you can move on to generations of computer and data and information. And in the second chapter, you will have to see some conversions along with the number system. Number system, in the sense, there are binary number system, octal number system, decimal number system, and hexadecimal number system, right? So decimal number system means normal numbers from 0 to 9, which we are using in mathematics. And binary number, in the sense, we have only two numbers, that is 0 and 1. With the 0 and 1, the whole number system is made for this binary number system. Since it is having only 2 digits, the base value is 2, right? And again, next one is octal number system. Octal number system, in the sense, we have numbers from 0 to 7, right? So 0, 1, 2, 3, 4, 5, 6, 7. So the total value is 8, right? Total number of digits is 8. So the base value of this octal is 8. Okay, and hexadecimal we have 16 digits, that is 16 values will be there, 0 1 2 3 4 5 6 7 8 9, and then we have a b c d e f. So total value are, we have 16 values, so the hexadecimal base value is 16, right? And here you will be learning the definitions for what is decimal number system, binary, octal and hexadecimal. Whatever I have said you now, that's enough for writing it as a definition also. You just go through the, in your book you can find it in 2.3.1, 2.3.2 and all. You just go through the paragraph, you just read it once and you'll be able to write it by your own itself. Okay. And number system conversion, next one is number system conversion. In this, first you will be learning about decimal to binary. Already we have done it in our class so many times. Decimal to binary means binary base value is 2, so you will be dividing the value with 2 and you will be mentioning the balance with the hyphen there. So you'll be getting the balance with zeros and ones. So from last, that is from MSB, that is from the last line left side, you'll be starting to write the value, and till the first line you'll be writing the balance values, and that will be the corresponding binary digit for any decimal number which they have given. Okay, so in this method you'll be converting decimal to binary. And the next 2.4 is for binary or any number system conversion. So the first type is decimal to binary, and in the next type is decimal to octal, and the next type is decimal to hexadecimal. For all these we will be following the same method, only the numbers will be different, right? So the base value of binary is 2, so we are mentioning 2, and for decimal to octal the base value of octal is 8, so we'll be mentioning 8 for decimal to octal, right? And the next one is decimal to hexadecimal. In this, the decimal value will be converted to hexadecimal. Hexadecimal base value is 16, so the value will be divided by 16, and you will be getting the balance till 15, right? Hexadecimal already we have seen it now. If it is 9, you can mention 0 to 9, you can mention the numbers as such. If it is 10, instead of 10, you will be mentioning as A. So 11B. So likewise, you will be mentioning A, B, C, D, E, F. Till 10 to 15, you will be mentioning like A to F, right? So these are the basic conversions in which you will be converting decimal to binary, octal and hexadecimal, right? And in the next part, that is conversion of fractional decimal. In this case, if you are having a fractional number in the sense you will be having pointed number. Before the point, one number is will be there. For example, if you see 2.46, if it is given, it is a fractional number. Since we are having the decimal point, and left and right side of the decimal point will be having the digits, so it is fractional decimal. Okay, so this fractional decimal we are going to find the binary value. In this case, for the digit which is before the point, that is left hand side of the point, whatever number is there, we can just convert the decimal value to binary in the normal form, normal common form. Now we saw, right, decimal to binary. With 2 you will be dividing and will be getting the balance as zeros and ones. In that case, we can just mention this fractional decimal left hand side of the binary decimal point, right? And the right hand side values, you have to mention it as 0 point, and you can write the right hand side value, and you have to multiply it with 2. So if you are having value like 0.2 means, if you are multiplying it with 2, you will be getting 0.4, right? So you will take the value which is left side of the decimal point. So the integer part you will take and you will be writing it aside, and in the right hand side of the decimal point you will be having a value. With that value, again 0.4 into 2, you will be multiplying it with 2, again you will be getting 0.8, and again you will be multiplying 0.8 into 2, so 1.6 will be there. So 1 you will be taking aside. If you are getting 0 or 1, you will be taking the value which is in the left hand side of the point, you will be taking it separately, and you will be keeping the value which is in the right hand side, and you will be multiplying it with 2. Okay, so in this method, you will be getting a repeated set of or series of a sequence of values. So if the values are repeating, you can just stop the calculation with that line, and you can take only the numbers from that from that integer part. Okay, so that integer part will be the binary value for this fractional decimal. Okay, so for this fractional decimal, for the left hand side of the point, you have already found it with the normal decimal to binary conversion method, and in the right hand side we will be doing it in this method. Okay, and the next one is binary to decimal. Binary to decimal, in the sense you will be finding the positional notation. Positional notation in the sense, first you will be having the binary values, right? So you will be splitting the binary values and writing it with some space, and from the right side you will be mentioning into 2 power 0, into 2 power 1, into 2 power 3, into 2 power 4. Like that you will be mentioning the values with powers. Okay, the positional value will be the power of 2, and you will be multiplying it with the corresponding binary digits. For the first digit, you will be giving 2 power 0. For the second digit, from right end, you will be multiplying, and from the right end, you will be mentioning 2 power 0. And the second value from the right, you will be having 2 power 1. Next, 2 power 2. Next, 2 power 3. Likewise, you will be mentioning, and you will solving the 2 power 0 means it is 1. Any value power 0 is 1. Any value power 1 is the same value. So 2 power 1 is 2. So if it is 0, you can multiply it with 0 and the value becomes 0. If it is 1, you will multiply with 1 and you will get the answer there. And at last you will add all the values and you will get the uh, decimal value. Okay, so this is the method to convert binary to decimal. Okay, and the next one is conversion of fractional binary to decimal equivalent. Fractional binary to decimal means, as we saw in the previous fractional decimal only, here also you will be having 3 steps. That is, first you will convert the integral part of the binary to the decimal value using the positional notation, as now we saw a method, right? So in the same method you will be converting it, and then to convert the fractional part of the binary, you will have to write down the binary digits in fractional part. Okay, and then for all the digits you have to write the powers of 2 from the left to right. From the left you have to write it like 2 power minus 1, 2 power minus 2, and how many values you are having till that 2 power n numbers, you have to mention it with negative values. Okay, and then you will multiply each digit with its corresponding weight, and at last you will add all the values which is obtained there. So for the value which is in the left hand side of the binary decimal point and also right hand side of the decimal point, you will be finding and you will be writing it together. Okay, and the other binary to octal also, in the class itself we have seen it so many times. Binary to octal and binary to hexadecimal, you will have to split the binary values into three numbers, and for the 3 numbers, if it is 110 means, for that 110 you know the octal value, right? So you will write the octal value for that, and for next 3 numbers also you will write the octal values. At last, it is in the left corner, if you are getting 2 numbers or 3 numbers, you have to add 0 to the left end, and you have to make the value to 3 digits, and then you have to convert it into octal, and at last you can add all the you don't have to add it, you have to just join or combine the octal values and take it and write it as the octal value. So that will be the binary to octal conversion, and same method only for binary to hexadecimal also. As you have seen in the class, here you will be splitting it into 4 digits, and in the leftmost value you will be adding 0 to it to make it a 4 digit, and for the 4 digit binary value you will you already know the hexadecimal equivalent, so you'll write the hexadecimal equivalent, and at last you can find the answer. So in hexadecimal equivalent also, if you are getting the values like 10, 11, 12, 13, 14, 15, you will be writing it as A, B, C, D, E, F. Instead of 10, you will write A, and instead of 15, you will be writing F, right? So the basic conversions are over, and the next one is octal to decimal conversion. Again, only two more conversions are left. Octal to decimal conversion. Here also same way as we saw in the binary to decimal, only here also the positional weight will be considering. The octal value you have to just split it out, split the octal values and multiply it with 8 power 0, 8 power 1, 8 power 2. In this method, you will just uh, multiply the value 8 power 0, 8 power 1, 8 power 2, 8 power 3 likewise, and you will multiply and add all the values at the end, and you will get the decimal equivalent. Okay, and octal to binary, same as we saw for binary to octal only. If you are having 6 to 1 means for 1 you know the binary value, so you will write that. For 2 you know the binary value, you will write it 0, 1, 0. For 6 you know the binary value 1, 1, 0. So in this method you will just split the values and find the binary number, and at last you will join all the numbers and write. That's all. And the next last one is hexadecimal to decimal conversion. That also same way. You will split the values and you will multiply it with 16 to the position. That is 16 power 0, 16 power 1, 16 power 2, and at last you will multiply those values and add all the values, and you will get the decimal equivalent. Hexadecimal to binary also, as we saw octal to binary only. The value will be, you will have to split the values and write 8, B, C means for C you know the binary equivalent. So you'll write the binary equivalent. B you know the binary equivalent. 8 you know the binary equivalent. At last you will join all the binary numbers and you will get the binary value for the given hexadecimal value. If you are finding difficult to know the binary values, you just write down the binary numbers in 3 digits and also in 4 digits and keep it aside in your paper, and for all the conversions you can make use of it, for binary to octal or octal to binary, hexadecimal to binary, or binary to hexadecimal. For all this you can make use of this itself. Okay, and the next one is uh, signed numbers, that is binary representation for signed numbers. Signed magnitude representation means here you will have ones complement and twos complement. Ones complement in the sense whatever binary value is there, you will just convert or inverse. 1 you will write as 0 and 0 you will write as 1. So that is the ones complement. If a positive number is given, if a positive decimal number is given, and if they are asking you to find the ones or twos complement, we cannot find it, because only for negative values we'll be able to find the, that is signed magnitude. Okay, signed magnitude representation. So only negative sign will be considered, minus sign will be considered as negative, and for negative number alone we'll be finding this ones complement and twos complement. And the process for ones complement is, if a decimal number is given, you will just find the binary value. You know, decimal to binary conversion, so you will just convert the decimal value to binary, and then for that binary value you will just invert all the bits. Invert, that is changing 1 to 0 and 0 to 1, that is ones complement. Done. And twos complement means we'll add 1 to the right end of the ones complements answer. When you are getting the ones complement, you will get an answer, right? So that ones complement answer, you will add 1 to the result, that is to the least significant bit, that is to the right end you will add 1, and that will be the twos complement for that particular value. So that's all. I think you're thorough with this conversions now. Already you would have studied, since you haven't returned this conversion for any exams. You just write it and study the conversions, so you won't have any doubts in this conversion. Simply if you are seeing it and going for the exam, you won't be able to do all the conversions. So take the questions from your textbooks and work it out and see. And third, fourth, and fifth chapter, I think you all studied it already. If you need, we'll revise it in Zoom session or in the next YouTube class. So today you just make the second chapter thorough. First chapter only the generation questions already you would have learned. If you haven't learned, learn it today, and learn the second chapter also thoroughly. Okay. So in the second chapter, if you are having any doubts, you just ask me through the Zoom session or through WhatsApp. In the second chapter, the main conversion is decimal to binary, decimal to octal, decimal to hexadecimal, and also binary to decimal is the important one. Here, addition, subtraction, so those things are deleted. So you can expect the compulsory question from this part, that is number system conversion 2.4 part. So go through all the subheadings in 2.4 and work with the problems also. Okay, thank you for your valuable time. Stay home, stay safe, take care.